Okay, so we are transitioning to arithmetic sequences today. We've actually already been looking at these in the earlier sections, just haven't called them by their formal name yet, okay? So first of all, notice how I worded that. I verbalized it as an arithmetic sequence. Don't say arithmetic sequence. Arithmetic is a noun. Arithmetic is an adjective that describes the type of sequence, okay? All right, so it's very simple. Your sequence is arithmetic when you have the same number continually added to get from one term to the next, all right? That number that's continually added is referred to as the common difference, okay? So in our example here, we have the sequence 7, 16, 25, 34. Notice we are adding 9 each time, so we refer to the common difference of this sequence as 9. Okay. Now we can have a common difference that is negative. So think if the terms that are up there, if they were reversed and 34 was the first term of the sequence, 25 was the next. To go from 34 to 25, you are subtracting 9, which is the same as addition by negative 9, right? So in that situation, you would call your common difference a negative 9. Okay? All right, here we have an explicit formula for a sequence. A sub n equals 2n plus 4. We want the first 4 terms, and from there, decide whether it's arithmetic or not. All right, so first term, a sub 1 would be 2 times 1 plus 4, or 6, right? A sub 2 would be 2 times 2 plus 4, or 8. A sub 3, 2 times 3 plus 4, or 10. A sub 4, 2 times 4 plus 4, or 12. All right, so we are getting a 6 followed by an 8, followed by a 10, followed by a 12. Does this appear to be arithmetic? Absolutely. Yes, arithmetic. And what is our common difference? So we'll say D equals 2. All right, now, seeing that this is arithmetic, go back and look at that explicit formula. A sub n equals 2n plus 4. Notice that's just a linear equation, right? So whenever you're arithmetic, your explicit formula is going to be linear in nature. Furthermore, notice the common difference of 2, that's the slope of the associated line. Okay? That's this 2 right here. All right? So let's say we are given the initial term a sub 1 and common difference d of an arithmetic sequence. We can use those to build the explicit formula. All we have to do is take that initial term of a sub 1 and add to it a factor of d that's 1 less than whatever n is. Okay? So explicitly, it just equals a sub 1 plus d times the quantity of n minus 1. All right? So think, like if I want the 100th term in an arithmetic sequence, all I have to do is take the first term of that sequence and add on 99 factors of the common difference. Why 99 if I want the 100th term? Because I already have one term in the sequence. Okay? All right, find the 56th term of this sequence. What is a sub 1? 3. What is the common difference appear to be? Positive 5. And then if we're looking for the 56th term, we'll say that n is 56. Now that term will be represented by the notation a sub 56. That will be equal to that initial term of 3 plus the common difference of 5 times 56 minus 1. Or that's 3 plus 5 times 55. Or 3 plus 275, which is 278. Questions there? All right, well, what about the recursive formula for an arithmetic sequence? Remember, recursive formulas, we are defining any given term of the sequence by a previous term in the sequence, right? Typically, it's like the term directly before the one you're trying to find. So for arithmetic, that just means take the previous term, add d to it, okay? So that's what we're seeing here. Recursive formula, a sub n is just going to equal a sub n minus 1, which that notation means the term directly before a sub n, and you're going to add d to it. And then, of course, don't forget you have to give the first term of the sequence, okay? So as long as we know a sub 1, as long as we know d, we can come up with both explicit and recursive formulas, okay? All right, we want a recursive formula for the arithmetic sequence whose fourth term is 3 and whose 20th term is 35. They don't directly give me a sub 1 or d here. I have to use what is given to reason those out. So saying the fourth term is 3, that means I can say 3 equals the initial term plus the common difference multiplied by 4 minus 1. I simplify that. That's 3 equals a sub 1 plus 3d. And then I can make a similar equation with the other information. The 20th term being 35 means 35 is going to equal the initial term a sub 1 plus the common difference of d multiplied by 20 minus 1. Or 35 equals a sub 1 plus 19d. Now notice I have two equations here with the same two unknowns, so that's a system. I'm going to solve the system with elimination. And I can do that just by subtracting here to eliminate a sub 1. 3 minus 35 is negative 32. 3d minus 19d would be negative 16d. And we'll divide this out. It's back. Thank you. Yeah. All right, so common difference is 2 there. Now use that to figure out a sub 1. Use either of the two equations at the top. I'll use the one on the left. That means a sub 1 is negative 3. All right, so now you can say your recursive formula here. Remember, you have to start, you got to give the initial term. So a sub 1 equals negative 3. And then the nth term, a sub n, would equal the previous term, a sub n minus 1, added with 2.